Okay, we're going to get started. This is HEVC versus AV1 and the future of the codec battle. And from a streaming perspective, the launch of AV1, I think, is going to be a significant milestone. How quickly it becomes relevant is something we're going to discuss during the session, but it's a really big stake in the ground as it relates to standards-based codecs and open source codecs. So I think it's a very strong move that's going to have significant shockwaves in the industry. To talk about that, we have 4 panelists who represent, some are on the Alliance for Open Media, but the cool thing about the Alliance for Open Media is it's comprised of people who are actually using the codec. There aren't any non-practicing entities, people who develop technologies to get royalties. It's a group of companies who contributed to the technology because they needed a technology that would help them accomplish, business purposes. So we've got Terry Fautier, he's from Harmonic, VP of Strategy. Mike Coward from Facebook, Director of Engineering. He's one of the practicing entities that will be using AV1, hopefully in the short term. Christopher Mueller, should be able to not mangle that name, who is CTO at Bitmovin, and Bitmovin is a member of the Alliance as well, and they are a company that has a player, but also an encoding farm and encoding capability. So they've been working with AV1 for a while and have some interesting demos here at the show. And Christopher will be talking about a comparison that he contributed to. And Mike is going to have similar data to a comparison that Facebook just launched today. And then last is Matt Frost, who is head of strategy and partnerships for Google, and he's going to hopefully spend his time talking about YouTube and a little bit about Chrome if he's able to get into it. I gave each panelist, the format for the presentation is, this is the last you'll hear of me. I'm going to give each panelist about 5 minutes to talk about their experience with AV1 and what they have at their booths, what they can show at the show, and then we'll take questions. So maybe 20 minutes to get to the questions, and then it's all about the questions that you guys have. So why don't we get started with Christopher Mueller from Bitmovin, who has a presentation. Can we switch over to that, please?
Yeah, thanks for the introduction, Jan. I mean, Jan described already some things. Bitmovin is a company that provides API-based products on the player space, encoding space, and also in the analytics space. The encoding is very flexible. Basically, it can run anywhere, on-premise, in the cloud, in your cloud, in our cloud. And this is the same thing, what we think about codecs. So we support HEVC for AVC, for example, HEVC, but currently also AV1. Our customers include some of them, like the New York Times, Periscope, Twitter, the Red Bull Media House, but also Cloudflare, for example, which are using our solutions here. I just wanted to present you some data that we conducted, I think in the middle of last year, what people are using. So basically, we asked around 400 developers what codecs they are using currently, and still the majority is using AVC, HEVC4. So 95%, but there was still a decent amount of people that were using HEVC at the time, so around 30%, and then some of the other codecs. I don't know what some of them did with AV1 at the time, but at least, I mean, they stated in the survey that they do something with it. And we also asked them, what formats or what codecs are you looking into in the future? And still, HEVC was leading here. 40% of the people responded that HEVC is a topic for them in the future, but also VP9 and AV1 were catching up on that end, because from my perspective, we live in a multi-codec world, and in the end, you probably have to support all of them to make your customers, your consumers happy. Beside that, we also created a data set which just got accepted at an international conference where we compared AVC with the implementation of HEVC4, HEVC as the implementation we have used HEVC5, VP9 with the implementation we have used VPX, and AV1 as the implementation that we have used there is just the AOM encoder, which is currently not really optimized, but I think in the end we will get there. We created different sequences, so we used 10 sequences that are typically used in standardization for comparing codecs. We really focused on AVR streaming, so we created different bitrate ladders from 144p and 100 kilobit per second to 4K with around 20 megabit per second. Segment sizes in that case were 2 to 4 seconds. At least what our results show here with that implementations, we saw that AV1 compared to VP9 brings significant bandwidth improvements. So on average, across the whole bitrate ladder, we saw a 13% improvement here. On the lower bit rates, it was less, and then it got higher and higher for the high bit rates and higher resolutions. We did the same comparison against HEVC, or in that case, X265. Why we used X265 here mainly because both are using a 2-bus encoding and not fixed QP in that case, where we think it's a fair comparison against a practical encoder and what is out there. For HEVC, across the whole bit ladder, we saw a 17% improvement when it comes to PD rate, PD PSNR. Also on the lower resolutions, it was less, and then it got higher and higher for the higher resolutions and higher bit rates. Another thing to mention here, what you can also see at our booth, for example, AV1 is currently in standardization, and the bit stream will hopefully be frozen soon, or a spec really fixed. But you can also see it in production more or less. I mean, we have a showcase where we show AV1 playback, encoding and playback in the Mozilla Firefox browser, but currently also in the Google Chrome browser, so in the canary beards of both browsers. But you can also see the benefits, and as soon as the bit stream is frozen, basically both browsers will support it, and you can potentially use it with your customers. Challenges that we see, obviously, if we use our own AV1 implementation, we see 10 to 100 times, or it's currently 10 to 100 times lower than X265, for example, or the VP9 implementations. But I think we're in the early days, in the early stages, and we can get there to at least be on par with the current HEVC implementations that are out there. There are massive improvements that can be done with the code base, I think so, not only on the speed perspective, but also on the quality perspective when it comes to encoder performance. So this is basically how to efficiently use the features that AV1 as a spec gives you. Thank you.
Okay, Mike is next. Can you put the Facebook presentation up?
Wonderful. Thanks, everybody, for coming today. Can you all hear me okay? Great. Great. My name is Mike Coward. I'm the Director of Engineering at Facebook, supporting the video platform. What I want to share today was the evaluation that we've done around AV1. Similar results, but a couple tweaks that I'll highlight. So we really compared AV1 against AVC and VP9. Those are the codecs that we have in production today. And very importantly, we used the production representative settings. So these are the settings that similar to the settings we use today in production for AVC and for VP9. In addition, we took 400 videos because we really wanted the content that's shared on Facebook is obviously different from the test clips that people use to develop the codecs. So we took 400 popular videos and then also a range of resolutions. We get a lot of 360p videos uploaded from people's phones all the way up through 1080p and higher. We tested in the 2 modes for AV1, constant quality and ABR. And one fun thing to highlight, every test run we had took 16,000 hours, which is about two years of CPU time. So we had to build a custom test harness in order to run this comparison. So we had a lot of fun. The high-level settings. So, and I should add, as you all take pictures, we released these results today. They're on a blog. I'll give you a link at the end. So please take pictures, but these results are all public as of today. Really looking at this in two versions, 2 flavors. You can look at the file size. I like to look at the bitrate savings. So starting from at the bottom left, if we compare main profile to high profile gets us a 4% savings. It's expected. VP9 gives us a 20% savings over AVC, and AV1 is giving us a 43% savings. Those benefits increase as the resolution increases. So at 480p, we're seeing a 49% benefit of AVC compared to AV1. At 720p, we're up to 50%. And then at 1080p, we're seeing an almost 58% improvement of AV1 compared to AVC. Another way to look at this is the savings, so comparing VP9 to AV1. And there, even at 360p, we're seeing a 29% improvement. All the way through 1080p, we're seeing a 35% improvement. So I think the highlight is obvious, but it's fun to see it validated in real data, which is that we know AV1 is delivering real benefits, of course over AVC, but also over VP9. As we would expect, the codec benefits do increase with resolution, but I think significantly for us, there's real benefit even at those lower resolutions. If you think about Facebook video, the users, we have a lot of users in emerging markets, older phones, slow network connections. And so being able to deliver benefits, even on low resolution video, is really exciting and important to us. Everybody's highlighting the same thing, which is the encoder performance. In our testing, it's taking us 5 hours per second of output. As Christopher highlighted, there's lots of improvements to come. So we're confident of that. I would say even with this performance, there are videos on Facebook that it's worth encoding, so it's worth us using AV1 for. So you'll be able to use it today and then extend as the encoder performance increases. Here's a link to the blog post, and love to take any questions through the panel.
Okay, thank you. Matt?
Thanks. So I'm Matt Frost from Google. I come from a team that does all of the development for our media compression technologies. So the team that developed VP8, VP9, and has now been working on AV1. We also do still image compression, audio compression, sort of cutting edge geometry compression to compress meshes and point clouds. And what I wanted to talk about a little is where we go from here in terms of like initial tests, very slow encoders, to something that people in this room can start to rely on. And as Mike said, actually, I think multiple people said, we already have something that is working in Chrome and Firefox as it stands right now in Canary. So if you download the development version of Chrome and Firefox, flip a flag, you can have AV1 decode working right now. As we are in the final stages of freezing the bit stream, those of you who've been reading the press, we are, or releases, we are in the process of concluding documentation of the AV1 bit stream, at which point the AV1 bit stream will be frozen and an encode that is encoded in AV1 on day one will be decodable 10 years from now in a compliant AV1 decoder. So what that means is that across these browsers, Chrome, Firefox, soon Edge, I can't talk about Apple's plans, but obviously Apple's a member of AO Media. We will soon have a really broad footprint of PC-based players capable of playing back AV1. And soon that will come also through software decoders to the Android ecosystem. One of the things that we're working on the decode side, which is work that we're also going to have to do on the encode side, is speeding up the decoder so that we can get the fastest possible performance on x86 and ARM platforms. And that's work that we're doing right now. I think presently the AV1 decoder operating in an x86 environment is about 5 or 6 times slower than VP9 decode. We think we should be able to get that down to 2 times as slow very quickly. It's a little slower on ARM, but again, we expect to bring that down to something that's really deployable very quickly. On the encoder side, I think with libaom, which is not it sounds like Bitmovement has its own optimized version. libaom is about 100 times slower, which, as Mike said, for the YouTubes, the Facebooks, the Netflixes of this world that have the processor power, have the time, and have really high impact content where it's worth spending 16,000 hours to encode, to encode Gangnam Style, because so many people are going to be watching it and the bitrate savings are going to be so profound. It's worth it. But we think we are presently working on AV1 encode optimization, and ultimately the goal is that we can bring that down to something like 5 times as complex as VP9. So that's something that really can be deployed by anyone without significant expense. In terms of next steps for AV1 adoption, obviously key to us all now is hardware adoption. And we have a team at Google that develops what we call hardware IP. These are licensable hardware designs that are taken by chip companies and used to quickly add support for AV1 on chips. And we just finished a trip to Asia where we were meeting with chip companies, and in general the message we're getting is 2 years for AV1 in hardware. So that would be 2020, we will see AV1 broadly available in chips that can power televisions, set-top boxes, mobile devices. So for, just to conclude, for those of you thinking about AV1, there is a very clear path for PCs very soon through HTML5 browsers, which really are the current generation media players on PCs and on mobile devices. And then hardware optimized software versions, GPU optimized versions are coming quickly. And from I think our perspective, YouTube is going to be supporting AV1 where possible on PCs very, very soon. We are already running test streams through YouTube, as it sounds like conceivably Facebook might be, maybe not through YouTube, but yeah. So.
Okay, thanks, Matt. Terry, you're I guess the sole kind of encoder vendor seller on the panel. What do you tell us about your HEVC? Tell us about your thoughts about AV1.
Yep. So, Thierry Fautier from Harmonic. So I'm running the strategy, and first Harmonic is powering half of the eyeballs who are watching TV today. I don't know about on internet, probably less, because Facebook, YouTube are quite strong and not using HEVC. HEVC, just to give you a background, standard developed in 2013, released 2013. Most application of HEVC today, Ultra HD, OTT for some operators, mobile, 50% of mobile smartphones are HEVC capable with license pay to the licensors. I see we have our friends of Dolby in the room. We have a lot of interest on terrestrial, ATSC3, DVB-T2, and I think DTH Greenfield are also going through HEVC. So this is a lot of broadcast application. I will challenge the group here. Where does AV1 stand on broadcast application? As you know, this whole exhibition is also about broadcasting, so it's an interesting topic. Harmonic is not an AV1 expert. So, by the way, we have deployed a lot of HEVC services being broadcast OTT, but we are very interested, even intrigued by AV1. So what we have done, we have taken AV1 reference code, February version. Thank you for making it stable. HEVC, which was released, I think, 2013, and I think it's still a golden reference. And we have run two types of tests. By the way, this was run by Beacon, independent organization doing research, contributing to GVET, so very sharp French research center. And we have run with them a test on very tough sequence. Sorry guys, there's a lot of gas, a lot of grass, a lot of sports, extremely challenging, and probably different from what you guys have seen on your sequence. Hopefully not posted on Facebook, because this is a lot of IPR behind those videos. But basically, we test those sequences in 1080p, HEVC, AV1 reference model. And I must say, I was surprised to see that on the objective testing, AV1 is always better, PSNR and VMAF. I'm sad to report on subjective testing, AV1 is always worse. Is it a rate control problem? Is it a way to understand how the tool works? So we do not come to the same conclusion as bit moving, because in Harmonic, we tend to watch the video. So at the end of the day, adoption of AV1 for us, I fully agree, 2020 is the right target. If there is an interest for an additional codec, which will, by the way, cost a lot more to encode, a lot more to stream, a lot more to store, if this is the solution the market has for this licensing problem of HEVC, so be it. The scope I want to announce here is, of course, Harmonic being an encoder company, a leader in encoding company, a cloud company, a SaaS company, will adopt AV1 when the market is ready for it. And if you want to see our demo, I'm going to do a small plug. You have under your seat an invitation. Booth is SU8110, and you can even win a drone, even if you don't like HEVC. That's all, John.
Okay, so let's start taking questions from the audience. Anybody have a question? Raise hands. Nothing? Can we go? Oh, sorry. And please, I don't hear so well. I've got to repeat the question, so please speak slowly and as loud as you can.
I have a bit of a hypothetical question to Google. Do you think the licensing is the only reason why, for example, Chrome is not deploying HEVC? And do you think if a miracle happens and HEVC is royalty free, it will be in Google and other browsers?
So the question is, does Matt think that the licensing structure of HEVC is the only reason it's not currently in Google Chrome?
So I would say right now, no, because we have VP9. You know, perhaps 4 years ago, had you asked me that question, I would have said, ultimately, Google's goal always, when we launched the WebM project and VP8 and VP9, was not to have this open source technology that we were created be the technology that was adopted as the royalty-free codec to be used in HTML5. It was to make sure there was a high-quality, rapidly evolving royalty-free codec that could be used in these browsers that all developers are giving away for free. And so if, we said in the VP8 and VP9 days, if H.264 high profile had been made royalty-free, that would have been a triumph. And obviously, our team maybe would have felt a little sad that it wasn't our technology, it was somebody else's, but ultimately what we're trying to do is to make sure that there is a royalty-free, high-quality, competitive technology out there. So if HEVC were made royalty, if the main 10 or whatever it is, were made royalty-free, I don't think there would be a reason to add it to Chrome right now because we have VP9 and we're concerned about Chrome size, but would that make a difference to the industry? Absolutely. So we are not promoting, and I assume this is true with Facebook and Bitmove, and we're not working on AV1 solely because, certainly we've brought together a group of companies who are not the companies that are typically participating in MPEG. Facebook doesn't, we go, but we don't do much. So I think that we've brought together a group of companies who've contributed to AV1 in ways that you haven't seen in the standards process, and we think have built a better codec. But really what we're trying to do is just make sure that there is a cutting-edge royalty-free solution out there.
You're going to have to really project.
I believe for the AV1 has good opportunity for the OTT streaming, but for the traditional linear TV, TV is what. Do you think AV1 can have an opportunity, or still dominated by?
Terry, can you repeat the question?
Good. Yeah, so the question is, for broadcast application, can AV1 be a player? So first, AV1, like I've seen the Facebook number, my numbers is a bit lower, it's 1,000 times slower than real time. So for all those broadcast application, live is important, okay? If I tell you, you have a head-end or data center which is this size of server. If I tell you for the same video quality, same bit rate, you need to multiply this by 100, which is basically populate 100 rooms. There is no business model for that, for live. For VOD, I believe you can do a lot of optimization. And I agree, as a user of an OTT service bundled with a broadcast service, the TV everywhere, it's a pain. I cannot have UHD on my Apple device because it doesn't decode UHD. So I think you cannot think only about broadcast, but also broadcast coupled with OTT. And the user cannot block them. You cannot say, for this content, change the browser. People will not accept that. So I think AV1 for that has some merits. But for live, I think you have to think at the business model, right? If you have an existing set-top box and you want to replace by another set-top box which has exactly the same performance, nobody's doing that. So operators are not doing that just to pay less royalties, because to change a box in a home or to wait for 100% of your subscribers are using your new box, even if it's not subsidized, but people have to go to the store, buy a new box. What you have at the end of the day is the nightmare, is the simulcast on a broadcast network. Nobody does that. On a unicast network, you double the traffic. So all those things, you have to do it in a smart way. So I think on the operator side today, it's wait and see until they see a benefit. Today, they don't see a benefit, but they are quite interested.
I have a question for Matt and a question for Mike. A question for Matt. You mentioned that you're working with chip companies. Are you, with Google hardware or Google designing like blocks for hardware? Is it for encoder only, decoder only, or for both?
It's for both, actually.
Repeat the question, please.
Yeah, so sorry. The question is, the Google team that's developing these hardware designs that we license, are we only developing a design for a decoder, for an encoder, or for both? And the answer is, when we release, actually, we expect that we will have a hardware design that does both AV1 decode and encode. So we're doing both, but unlike previous generations, we aren't coming out with a decoder first and then an encoder afterwards. We actually think we should be able to achieve both at the same time. And sitting right to your left is the person you should talk to if you're interested.
Whoa. This is a matchmaking, huh?
Yeah, exactly. Unless maybe he put you up to the question. Yeah.
Question for Mike.
Of course.
There's Facebook, there's a lot of live streaming these days.
Sure.
Would you still use AV1 for live streaming and video on demand, or only for video on demand?
So I think the question was, would we use AV1 for live streaming and for VOD, or for one or the other? I think today with the encoder performance, clearly AV1 as it sits now is optimized for VOD. So we do expect a lot of performance gains, and as the performance gets towards real time, then we'd absolutely consider it in part of our arsenal.
And if I could just add one thing, the encoder is slow. A number of companies that were participating in AOM, Cisco, Microsoft, Facebook, and Google have very significant live properties, and we had a very active, real-time working group that was very focused on making sure that we were designing this for real-time encode. So it'll take a while. The optimizations for live come a little slower than they do for VOD because you have to make intelligent choices about what tools to use, but they'll come. And then the other thing I'd say is, and you can see here, there are a growing number of companies that are focusing on hardware encode. And I think that's another solution potentially for live, true hardware chip-based, ASIC-based, or FPGA-based encode.
I got that question at the show already several times, and the specification is not preventing you from doing live. So it's just about speeding up the encoder. I mean, we have a live stream at our booth. It has 2 minutes delay, but it's still live. And if we would further optimize on the encode side, we can obviously get the delay down. So there's nothing in the specification which prevents of doing live.
So maybe Jan, if I can interject. So what's interesting, when you have a complex encoding technique to implement, in the classical server appliance approach is very difficult. In the cloud environment, you can, as you know, use more nodes. And if you don't have too many assets to encode, I think this is a smart way. If you think of a DirecTV 1000 channel to encode times 100 servers, this could become prohibitive. So you guys need to think, VOD, live 24/7, just one session of 1 minute. So this is where the cloud takes, I think, us to a different discussion, as opposed to really just what is your chip doing, but what is the technology enabling us to do in order to do things we never thought before.
I'm getting the feeling you think encoding time is a problem in the live application, is it?
Yes, but let's take the VR example. VR is a typical example. People tell me, oh, I have an event, it's only 1 hour, and I need a massive amount of computation. With cloud, you can do it. with a classical approach, it's impossible.
Well, unless you have hardware, I think there will be real-time hardware coming. It's just a question of time. Maybe that doesn't scale as well as the cloud, but even, the Amazon cloud has FPGA machines that you can access and upload code to that function like hardware encoders. So I don't, these are the very early days of AV1 implementation. I think you're correct. In the next, 12 to 24 months, it's not going to be suitable for much live applications. But I think beyond that time frame, we'll just have to see. But let's kind of move on from live because I think we've all talked that.
You said that objective quality was much better than matches with what we saw, but subjective was much worse.
No, I'd say it was better and worse, not much. And you have to come to my booth, so it's as you.
Those are my questions. Like, when you look at objective numbers, those are huge numbers, like improvement-wise, but if subjective is much better, also worse. What's your analysis of why that?
So
repeat the question.
The question was subjective versus objective on the analysis. So for those who have been working on video compression, PSNR and VMAF doesn't correlate to the real quality that your eyes is watching. Yes, VMAF reproduced the pattern of PSNR. Isn't it interesting? You see the same pattern. They score at different scale, but it's exactly the same order on all the test sequence we have encoded. Again, you have to come and see, because people say, okay, is it real? We show the sequence, and the second announcement I wanted to make, because I saw Bitmoving put a blog, we have a paper at IBC where we are going to make a very formal presentation and hopefully be accepted for the final paper. But in between, we will publish the results. The reason we could not publish anything is the simulations are so slow. It took us months from February to now to encode.
Well, you're
I'm not
talking
saying
about
it's
it.
too complex to encode. But we will publish all the data, and this is public sequence, this is public code. You will be able to rerun the experiments. And I hope Harmonic is not telling you lies. This is not fake news.
I think the whole benchmarking thing is really fraught with issues. And you're here saying the positive ones from AOM members, but they're all users. I mean, if Netflix puts out numbers, it's because that's what they're going to use in implementation. These are not academic numbers. These are actual production numbers. And these are people who want to use it, and they're not testing to try and make good numbers either way. It's like, this is what we think we're going to do during encoding. This is what our findings are. And I think, when you judge a paper, I think the first thing you have to look at is there a vested interest? And there's a lot of the papers I saw, Netflix says this, and I trust Netflix a lot because they're a user. But there's a lot of papers by academics who just might be associated with MPEG who find no benefit to BP9 or no benefit to AO media. And these are non-practicing people who are associated with the committee. So I think, and there are good papers, there are bad papers, and I don't mean to criticize anything broadly, but I put a lot more stake in a paper that's being produced by somebody who's actually using it. When Netflix says 20%, 30%, when Facebook says it, that means something to me when Bitmoving says it, because he doesn't want to sit here and say, okay, we get 30%. When you come to him as a customer, oh, no, you can't get that. Sorry, it was wrong. I mean, people who are using it, those are the numbers I trust. And Harmonic is a user, so I mean, I'm not criticizing them, but really scrutinize who's writing the paper and their connection to both AO Media and the MPEG committees. But let's kind of move on. I get the last word but any other questions?
Given the evolution of digital technology, I'll just put this out to anybody. I know this might be a loaded question, but are you thinking that AV1 will actually become the standard codec that everybody will use in the future, or will there be always something new that will be developed? And if so, what time frame are we looking at?
So what is your future definition?
Within 5 to 10 years.
Okay, so maybe I can repeat the question. What is the future codec or the codec of the future?
Well, is AV1 the codec of the future within 5 to 10 years?
I cannot comment on AV1 because I think everybody agrees it's an early day. I can only say that for the future, there is an MPEG meeting next week where they are going to pick the tools for the next generation video compression codec. This is a heavily loaded pattern codec, so it might not be successful, but this is if you look at our demonstration on our booth, we compared AVC, HEVC, AV1 versus JVET. So you will see JVET is way ahead of AV1 today.
Yeah, I guess the counterpoint to that is, HEVC wasn't a technology failure, it was a business model failure. And, I think we've until the MPEG committee, the chairman of MPEG said it himself, until there's a reformation of the business model, the codec's not going to be successful. So I think that's the lesson of HEVC, the business case studies that will be written. It was a fine technology. It was introduced at the right time. It really should have been broadly implemented, but the royalty structure is still unclear today, 5 years after it launched. And I think that's what spawned the AO Media Group. And I think that's what killed HEVC. And I personally think that the broadcast is going to continue with HEVC for, there's a lot of deployed infrastructure. There's a 2-year wait period on both live and playback and hardware. But so I see 2 codecs going forward at least for the next 2 to 5 years. And beyond that, I don't think anybody has a relevant opinion. But if you guys want to share your thoughts.
Yeah, I mean, I guess I would say there is certainly still a need for us to continue to improve video technology. At the high end, 8K appears to be coming. Certainly, high frame rate. You look at what the latest iPhone captures. Not more than 240, 240p, 4K video. That's going to make its way to YouTube and to Facebook video. For Oculus and YouTube 360 type experiences, you need high frame rate, high resolution. Even if your viewport is only full HD, the entire sphere is 8K. So, and then at the low end, which is really very important for Facebook and YouTube, there is still progress to be made. And I think one of the things that was most inspiring at NAB for those of us who saw it was Netflix showing an AV1 demo at about 100 kilobits, very, very, very viewable. 720p at 200K. So you think about that for the next billion users, for people who are coming in over 2G networks in India. We may be focused here on the very high-end experience, but for lots of people, the low-end experience, what we consider the low-end experience, is their high-end experience.
And maybe the last thing I'd add is, we live in a world where people use phones for years. We have a variety of chipsets. So we operate today with many codecs. I expect 10 years from now, we'll be shipping. We'll still have people watching AVC. We'll have people watching AV1. We'll have people watching AV2 and 3. Maybe some of the MPEG standards. So I think when you get to a certain scale, you become a multi-codec company.
I have a technical question for Mike. Why did Facebook decide at some point to go with VP9?
Sorry, why did we decide to go?
Why is Facebook using VP9? For which kind of stream?
I think you can see from the graphs, VP9 offers improvements, and so for
high resolution or small resolution?
both. You can see from the graphs that there's benefits at low resolution, there's benefits at high resolution. With both codecs, the benefits scale with resolution, but we have people all around the world that watch low resolution streams as well.
Okay, a couple more questions. Did you have one?
Yes, I'm curious about harmonic on the test you did for that. I guess you used your subjective assessment. Was that literally people watching it, or was there some algorithm or metric that you used that you would consider as close to subjective?
So subjective or objective testing on harmonic. So for the objective testing, is people sitting in a room. We put 10 video engineers with ranking from 1 to 5 on the BT500 process. If you know BT500 methodology to rank. So that's what we did. Of course, people will have, you take 10 engineers at Facebook, they'll have a different opinion because maybe they don't care about the grass as much as we do. We've been taught here all our life on soccer, you get obsessed. Fixation. But it's a good test pattern. We are quite happy. Of course, it's more broadcast content compared to YouTube content, but it's high resolution. It's terrible.
So is there a question in there? Or?
Yeah, so it's not a statement, it's a
Question.
So I guess I would say, speaking only.
I guess
right. So the question is this is a sort of a rephrasing of this is AV1 the one format for a given point in time? I will say for web video, which is, one thing I think we should mention is that the companies that belong to AO Media are companies that are focused on web video, and obviously there's tremendous convergence, but we really have not focused on the broadcast industry, and a codec's a codec, and the exception of maybe interlacing and deinterlacing, a codec that is designed for the web can be applied to broadcast, but answering only for web video, I think when you look at the companies who are on the board at AO Media, it includes the companies behind the two major mobile operating system. It includes all the browser developers. Again, not speaking for Apple, simply because a company is a member doesn't mean they're going to support it, but it certainly looks, I think, promising. And that's obviously one of the goals that we always had was with VP9, we have had great penetration. We have billions of endpoints. We have much broader penetration in HTML5 players than HEVC does, but obviously Apple is a big hole in the world. It matters less in India than it does in other places. And then just answering the broadcast question, I think, again, we don't focus our attention on broadcast, but a codec's a codec, and certainly we've heard interest from broadcast companies and alliances about AV1.
So, Jan, I would like to make a comment. I'm going to talk on behalf of Apple. Imagine iPhone 12 is AV1, and all the other phones at that time are all AV1. You still have iPhone 11, 10, 9, 7, maybe 5 will be dead. So all those phones, you need to feed them. It's HEVC. So even if you think you have the magic codec, you will have tens of billions of HEVC devices to feed. And I don't think any of those companies here want to cut themselves from the 90 or 95% of the install base. Always think install base, never think new device.
I think, if you talk to Netflix, they're still encoding Windows Media for some of their older devices. So, I think it's, the different vendors will take different positions on that, but I think, certainly if you're a full service OTT provider, you're going to err on the more codecs and not piss off your customers. So I don't see any day where it's one codec only. Those days are unfortunately behind us.
Yeah.
Okay, one more question. Who wants to be the lucky person? Okay, we have ice cream in the back. Leave some for the speakers, please. And thanks for your attention and attendance.
Thanks, everybody, for coming.
Thank you.